This is part one of my solution to the first formative assessment on evaluating algebraic expressions. And I'm just going to go through the first problem here. And remember, these first three problems are really, when we evaluate algebraic expressions, or in this case, just numerical expressions, we're just really using the order of operations. In this first problem, I see addition, multiplication, and subtraction. I have three operations. And so I have to decide what order I'm going to do them in. And you can see that the subtraction is grouped here inside these parentheses, indicating that I should do that first before I engage in the other operations. So let me do 5 minus 8. That gives me -3. So on my next line, I'll do the subtraction. And there we are. It's a little bit simpler. Now there are only two operations. So I have addition and multiplication. I will continue by just doing that multiplication. 3 times a -3 gives me -9. And then when I add 1 plus -9, I get -8. Just a reminder, it is appropriate to work down the page, and also on each line of your solution, you are writing a complete equivalent expression to the original one. This one's a little more tricky, but only because there's maybe one more operation. We throw a couple of exponents at you. But remember, the brackets are just a different way of grouping operations. So on this problem, I look inside the brackets and try to figure out which operation I should do first. And I see inside there's a subtraction and an addition and an exponentiation. But again, there's more grouping happening inside there. So I look inside that grouping and I see a sum, 1 plus 1. I'm going to do that operation first. And I get 2. And I copy the entire expression down. It's a little bit simpler now. Once again, I got these brackets that are grouping these two operations, subtraction and exponentiation. Again, in the order, I would do the exponent first, so that's 2 squared, 4. So I get 1 minus 4 inside my brackets, and then I'm squaring that difference. Now, I need to finish the operations inside the brackets before I can deal with this exponent. Some people struggle with this, but you cannot distribute this exponent and square the 1 and then square the 4. That's not allowed. Instead, let's just evaluate what's inside of there, -3. And when I square that, I get a +9. -3 times -3 is +9. And this last problem in this one right here, in problem number 1, is kind of designed to be really challenging if you just imagine multiplying out these 2-digit numbers. And I see a lot of solutions where kids are scribbling out the multiplication algorithm over here. We're not going to do that because once you've done all this multiplication, you end up with these really big numbers on the top and the bottom of your answer, and it's really hard to reduce them once you have those really big numbers. So we're going to, instead of multiplying and then reducing, we're going to reduce and then multiply. And let me show you how we do that. I'm looking for common factors on the top and the bottom. First, immediately I see a 5 here and a 15 up here. So I can reduce those by 5. Effectively, this becomes 1 and this becomes 3. So what I really just did was I divided the top by 5 and I divided the bottom by 5. And I want to keep looking for common factors on the top and the bottom. And it is the properties of multiplication that allow us to do this. And we'll talk a little bit more about that in class. But here I have a 24 and an 8. Well, 8 goes into 24 3 times. So I can do that. And then again, maybe you see the common factor here is 7. So if I divide a 7 out of this, I'm left with 3. And if I divide 28 by 7, I'm left with 4. So that is a much more manageable multiplication problem. 3 times 3 times 3 divided by 1 times 1 times 4. So on the top I get 27, and the bottom I get 4. I think for a minute about how I might reduce that. I don't see a common factor on the top and the bottom. I could leave my answer like that. Some students choose to write it as a mixed number, which would give us 4 goes into 27, almost 7 times, but really just 6 times, and that would leave me 3/4. So either one of those is fine. I prefer an improper fraction for my solution there.